bắt đầu chuẩn bị chị Anh bắt đầu lên. Đến 15 phút rồi ha.
But I'm proudly introducing Mom. She's a wonderful student, and then at 5 weeks into the research project, they are spending 8 weeks with me, and I told her to stop all her experiments and start working on her essay and her presentation. And she looked rather puzzled, and she says, don't you want me to finish all the isolates? Because she finished 58 isolates of my 150 collection of Bordetella pertussis. But this is very impressive. Now I said, it's time for you to take ownership of your data and give the best of your presentation. I'm so proud of what she did. Thank you.
And thank you all for being here today. So today I'm going to talk about my research project, which is to identify the 58 clinical isolates of Bordetella pertussis archived at Seattle Children's Hospital by looking at their FIMBRA3 gene, which I refer to as FIM3, and pertussis toxin subunit, which I refer to as PTXS1. So by the end of this presentation, I hope you'll be able to understand the importance of this research in studying the antigen shift hypothesis and input for pertussis acellular vaccine update. Also, you'll be able to describe the amplification refractory mutation method using the study and describe the relevant results found in 58 clinical isolates of Bordetella pertussis. So Bordetella pertussis is the causative agent of whooping cough, a disease that is most prominent in young children and infants. Adults and adolescents can also be affected, but the symptoms are much less severe. Due to the high mortality and morbidity of this disease, in the 1940s, whole cell vaccine was introduced and was found to have many side effects. So in the 1990s, acellular vaccine was introduced in the United States and was very effectively against the pertussis infection. So in the U.S., there have been 4 licensed acellular vaccines so far, and they are different in their components from each other. All of them have the inactivated pertussis toxin and 2 or 3 more antigenic components like filamentous hemagglutinin, pertactin, and FIMBRA203. However, there was an increase in incidence of pertussis infection in 1995 and 1996. There have been multiple suggestions to why this is. For example, it might be due to the improved surveillance of pertussis infection, so there are more cases to be found, or improved diagnostic technique, or a waning of vaccine immunity, so that there's an increase in cases in adolescents and adults. Our hypothesis is that the inclusion of Bordetella pertussis FIM3 gene and PTXS1 product in the vaccine may be a selective pressure to induce antigenic shift in the circulating isolates. So I studied 58 isolates at Seattle Children's Hospital by sequencing the FIM3 gene and investigating polymorphism of PTXS1 gene using the technique that I will describe in detail. So the first part of the study is to analyze the FIM3 gene. There have been 3 known subgenotypes of this gene, denoted FIM3A, 3B, and C. And the coding region that contain these mutations were then analyzed using the ABI PRISM genetic analyzer and the gene bank homology to identify the polymorphism of this sequence identification. Out of the 150 isolates at Seattle Children's Hospital, I analyzed 58 isolates, and due to time limitation, and our result shows that from 2002 to 2008, FIM3A subgenotypes show up in 18 to 33% of the isolates. FIM3B show up in 66 to 100% of the isolates tested. Noted that in 2007, I tested 7 isolates, and all of them were found to be FIM3B. So on average, the subgenotype FIM3B is the predominant among these isolates. And this result is also consistent with findings in other areas of the U.S. when tested isolate collected after 1995. So the second part of the study is to study the polymorphism of PTX-S1 gene using the amplification refractory mutation system. So this table is showing 4 subgenotypes of the PTX-S1 gene, A, B, D, and E. And these subgenotypes are different from each other in the hotspot mutations that's shown in this picture. In our study, I chose 3 positions, 586, 684, and 694 to do my analysis on. And this method includes 2 PCR reactions. They have the same reverse primer. Their forward primer are different in the 3' terminal ends. And the products of these PCRs are then analyzed using gel electrophoresis. So because there's not much difference in the forward primers, there will be non-specific products and specific products. As shown in this picture, this is the example of a gel electrophoresis. I'll use this position 586 of isolate from 2002 as an example. As shown here, the primer that ends with T produces more products because of a more intense band as opposed to primers that end with C at the same position of the same isolate. So our reasoning is that in this isolate, there must be a T at position 586. And the same reasoning was applied for the rest of the isolates. Our result shows that all of the isolates tested, 34 out of 58 isolates, show to be of subgenotype PTX-S1A with a T at position 586, A at position 684, and A at position 694. So in summary, the predominant subgenotype is FIM3B and PTX-S1A, and this result is also consistent with findings around the world. Some highlights are 68 Canadian isolates from 1994 to 2003. 70% of them were found to be FIM3B. And the PTX-S1 genotype is also predominant in France, Finland, the Netherlands, and Poland. So my finding seem to support the hypothesis that the polymorphic changes in FIM3 gene and the PTX-S1 gene suggest the antigenic shift in the circulating isolates. This is also in support of the theory that of pertussis adaptation to vaccination. This study is important because it characterizes the pertussis circulating isolate strains in the Pacific Northwest, and it may provide new information to future vaccine improvements. So I'd like to thank Dr. Shin for all her help and the laboratory staff at Seattle Children's Hospital for guiding and supporting me through my research enrichment. And thank you all for your attention.
Okay.